In this lecture, we'll explore the SQL basics and the basic commands that we can use in SQL. This is the example setup that we'll be using throughout this lecture and the next lectures. We have 5 tables here: employees, departments, salary grade, equipment, and employee equipment. Just the first 2 will be used for most of the time, just the employees and the departments. The employees table has 8 columns, and the departments table has 3 columns. The first column for each is a primary key. Then you have the name, job, manager ID, hire date, salary, commission, and department ID. So the employees table contains the details for employees in a company. So the ID is just a primary key, which is just an incremental value in the database. This is not the employee ID. The name is the name of the employee. The job is the job title of that employee. The manager ID is a foreign key reference to the manager table, which doesn't exist here in our universe. The hire date is the date the employee was hired. Salary is the current salary of that employee. Commission is the commission rate, if it exists, for the employee. And the department ID is the foreign key for the departments table, where we can see which departments the employee belongs to. And the departments table has a primary key, the department name, and the department location. So this is the data that we'll be working with as well. So this is the employees table, and this is the departments table. So setting up the database system, setting up the database, and setting up these tables and loading this data are all part of the first demo, which you can follow in. The first command and the most important command is the select statement. The select statement is the most popular one as well. It's used for retrieving data from the tables. So you can retrieve from individual columns with select name from employees. So in this case, we're specifying the specific column from the employees table. You can retrieve multiple columns by using a comma. So select name, comma, age from employees. So that will return 2 columns. Or you can return all the data from the table by using a wildcard, which is the asterisk. And it's best not to use the asterisk unless you really need to, because that's going to be an expensive trip in terms of the performance. Now that we retrieved data, we can sort the data. By default, the results are shown in the order that the data is stored in the database. So the order by clause takes the name of one or more columns by which you want to sort the results by. The order by clause should be the last clause in the select statement. You can also sort data by a column that's not currently being retrieved. This is because the order by happens before select. So in other words, the entire table is retrieved, then ordered, then restricted to just the name column. So when the ordering part was happening, we did not restrict to certain columns with the select. The execution order is going to be from, order by, and then select. If you want to filter the data that you're retrieving, there are several ways. The where clause is a filter condition. So you can do select columns from the table where something equals something. So in this case, we're saying select name from employees where the job equals analyst. So in this case, we only want to retrieve the employees whose job title is analyst. So in the example here, we're doing select name from employees, order by name. So in this case, we are sorting by the name alphabetically. Filters. So there are several ways to filter results. One of them is using the where clause. So you're doing a select columns from a table where something equals something. So here we're saying select name from employees where job equals analyst. So what's happening here is we only want to retrieve the records where the job title is analyst. So we only want to see which of those employees are analysts. And then we're also doing an order by name in order to get those records in an alphabetical manner. And also please take note of where the where clause is and where the order by is. These are some of the other operators that you can use in the where clause. So you can use the equality, the non-equality, the less than or equal to, greater than, between, and is null. Now you can see that there are different types of different ways to do the non-equality and the greater than and so on, and the greater than or not less than and so on. So that's because the different database systems have different syntax. So that's why you need to check to see which version of SQL, the system that you're using. So you need to check with the documentation to make sure that the syntax that you're using is compatible with the database system. So the T-SQL might support some things, which is the Microsoft version, and the PL/SQL, which is the Oracle's version, might have a different syntax. Range. So if you want to get records for a certain range, then you can use the between and. So in this case, we're checking select name salary from employees where salary is between 2000 and 3000. So in this case, we are filtering for the salary field with a between and. No value. So this is a tricky one because when a table is created, the table designer can specify whether or not the individual columns can contain no value. So a null value means no value, and that does not mean it's a zero or a blank or just something in quotes. None of that. A null is just a null. It's just something, it's just void, doesn't exist. It's sort of like undefined, if you will, like a divide by zero or something like that. So the select statement has a special clause. So the select statement has a special where clause that can be used to check if the column is null, and that's the is null clause. So you can say select name job from employees where manager ID is null. And in this case, we're getting one record for Kaling, who is the president. So in this case, we're retrieving the name and job. So since she's the president of the company, she doesn't have a manager. Now to filter by more than one column, you can use the AND operator. So you just append the conditions to the where clause. So you can just do a select name job from employees where manager ID is not null and salary is greater than 3000. So in this case, we're getting two records here for Scarlett and Frank, who are both analysts. So we can also see that we're filtering a field that we're not retrieving here as well in the where clause. The OR operation, it's similar to the AND operation, and in this case we can use it, and we can use it to evaluate if one of the items meets the condition. Now in most database systems, if the first condition is met, then the system is not even going to check for the second condition. So it's automatically going to return true. So for example, here we're saying select name job from employees where job equals salesman or analyst, and that just retrieves all the rows that meet the first condition. And if you do another query where you say select name job from employees where job equals analyst or salesman, so in this case we swapped the analyst and salesman, then that's going to return only two records where you get the Scarlett analyst and Frank analyst. So this is kind of a tricky thing which can be prone to errors. So you want to be careful because the order actually matters and the database system doesn't care to check the second part of the clause. Now as we've seen, the where clause can contain any number of AND and OR operations. Now when you combine these two, you can perform some very sophisticated and complex queries. The AND always ranks higher in the order of evaluation. Either way, it's best to use parentheses, because parentheses will always rank higher regardless of anything else. And also, like the issue we saw earlier, different systems might process the statements in a different way. So it's always better to just use parentheses. That way you can be sure that the logic you're trying to convey is being understood by the processor. The in operator. This allows you to specify a list of values in the where clause. So here we can say select name job from employees where job in analyst salesman. So this is actually what I wanted to retrieve earlier with the OR statement. So I wanted to see all the records where the job title was salesman or analyst. So the correct way of doing it is by using the in and then parentheses and then the list of values that you want to use. So you can have a long list of things here. The not is the opposite, so you can do not in, and it's a similar thing. So you can say select name job from employees where job not in the list. So you'll get everything else except those two. Wildcards. So wildcards are special characters that are used to match parts of a value. You can also use them to search for a pattern. So with wildcards, you can use the word like, and then you can specify in quotations a partial word, and then you can use wildcards. So here we're saying select name job from employees where the name like MA percentage. So in this case, we're saying retrieve all the rows from employees where the name starts with MA. The percentage can be used at the beginning, middle, or end. So here we have where name like percentage Z percentage. So we want to see the records where Z is in the middle. And then the second example, we have S percentage E. So here we're saying that it should start with S and end with E. The underscore. The underscore is used as a wildcard to escape just one character, to get just one character. So here we're saying select name job from employees where name like and then underscore rank. So in this case, we're looking for rank. So it has to be exactly one character. Square brackets. You can use square brackets with wildcards to specify a set of characters. So this is one of the commands that differs depending on the database system that you're using. So if you're using MySQL, then you'll have to use regex, which is the regular expression. And then in quotations, you need to have the upper tilde and then square brackets, and then provide the characters for the regular expression to match. So in this case, we're saying where name and then regex ms. So that's basically saying that we want to see all the records which contain M or S. So for example, if you're using Microsoft SQL Server, then you don't need to use that regex. In that case, you just need to put square brackets, and then you can just provide the characters that you want to search for. So this is more of a syntactical thing, which might do, but the functionality is the same. So when you're using wildcards, you have to be pretty careful because they're extremely powerful. Sort of like, so it's similar to the first select statement, where if we do select star from table, then they'll just retrieve all the columns and all the data from the table. So that's going to be that's called a table scan, and that's a huge performance nightmare. So you want to retrieve as little and as specific amount of data as possible, but at the same time, if you create too complex a query just to retrieve a small amount of data, that still could be a bad thing. So there's also the query execution time that you can look for while building and executing a query. That's more of a database topic, but we'll look at the performance tools in one of the demos. So when you are using wildcards, it's best not to use them at the beginning of the statements. That will increase the number of searches and the amount of data that needs to be scanned in the database. So data stored within a database's table is often not available in the exact format that you may need. So unlike all the other columns that we retrieved so far, we can also get calculated fields. So the calculated field data does not directly reside in the table, and the calculations are made on the fly. So this happens within the select statement. So the most frequent use of calculated fields is to do basic arithmetic. So for example, select salary plus commission from employees where name equals Adeline. So in this case, we're just adding the values of two columns, that's the salary plus commission. Concatenation. So concatenation is where you're concatenating two separate columns, the data from two separate columns. So again, this is also another syntax thing where if you're using MySQL, then you'll have to use the concat function where you have to write concat and then parentheses and then the columns separated by a comma. And if you're using Microsoft SQL Server or Oracle, you can just use a plus sign or you can just use two pipes. There are also some settings for these database systems where you can go to the options, or there's like an options file, and you can enable some of these features in order to help with compatibility. Because sometimes you might be doing data migrations where you're bringing a lot of data and tables and some schema from Oracle, let's say, to MySQL. And in that case, you might even be bringing a lot of data as well. So if you need the compatibility to work and you don't have to rewrite a lot of the code that's already been written, then just because of the syntax difference, then you can look for the documentation and look to see if you can enable certain flags or change certain options in the database in order to allow for the syntax to work across different systems. The trim function. Trim function trims space on both sides of a string. So if there is an extra space on one side of a string, the trim function trims it. And there are also sub functions called rtrim and ltrim, and as you might have guessed, the rtrim removes space on the right and the ltrim removes space on the left side of a string. Aliases are used to create a custom temporary name for a table or a column. So the alias names are only temporary and they only exist during the duration of the query. Using aliases are pretty useful because that way you can actually show the name that you want to use instead of the actual column name that exists in the database. So in the example here, we're saying select concatenate name job as employee name and their job title. So you can see in the result that it says employee name and their job title. This is actually a lot less common. So in most cases, you just use one word instead of having an entire phrase. Functions. Functions are operations that are usually performed on data and usually to facilitate conversion or manipulation. An example of a function is the rtrim or the trim that we already saw before. Most SQL implementations support 4 types of functions. You have text functions, numeric functions, date and time functions, and system functions. The text functions are typically used for converting values to two upper or two lower, like uppercase and lowercase, and the rtrim, ltrim that we saw, or to get a substring from a string. The numeric functions are, for example, mathematical operators or absolute or floor, top, and so on. Date and time functions, like for example, you want to get the number of days between two separate dates, or change the format of a date, or retrieve only the day or just the month of a date, and so on. And system functions, finally, are those that are more administrative, like get the username of a person or get their role or retrieve information about the database. So these are examples of the text functions: length, lower, odd trim, raw trim, upper, date and time functions, make time, microsecond, minute, month, now. Now is an important one that gets the current date and time. Numeric functions, plus, minus, mod, absolute, and system functions. If it's MySQL, then you can get the benchmark, which is the execution time, the amount of time it took for the query to process. This is useful. The character set of the database, the collision, the current user, which gets the username, and the first row, last row, and the schema of the database. The aggregate functions are used to help summarize data without actually retrieving it. So these are special functions. So far we were just retrieving different rows. So in this case we're compressing or summarizing multiple columns. So if we can get the average, returns a column's average value, count, get the number of rows, max, the maximum value, minimum value, and the sum. So here, for example, select average salary from employees. So you get the average salary across all employees. Count star, where job equals manager. So this is to retrieve the number of managers in the company. And the max salary is to see for the job title manager, what's the maximum salary someone is currently receiving. Distinct. So distinct is used to retrieve only the unique values. So in this case, when you use distinct in the select statement, you will get the unique rows. You can't use distinct for calculated fields. You can only use it with a column name or with count star. Grouping. So grouping is an important feature. Grouping lets you divide data into logical sets so that you can perform aggregate calculations on that group. The groups are created by using the group by clause in the select statement. In other words, the columns that you are specifying to group are evaluated together. If an expression is used in the select, then that same expression must be specified in the group by as well. So aside from the aggregate calculation statements, every column in the select statement must be also present in the group by clause. The group by clause must come after any where clause and before the order by clause. The group by clause can contain as many columns as you want, so this helps you nest groups by providing you with a lot more control. So if you nested the groups in the group by clause, the data is summarized at the last specified group. So this sort of works in a recursive fashion. Aliases can't be used if you're using the group by. So here's an example. Select job count star as the number of roles from employee, group by job. So in this case, we're trying to count the number of different roles in that company. So there are two analysts, 4 clerks, 3 managers, 1 president, and 4 salesmen in that company. Having. The having clause allows you to filter which groups to include and which to exclude. So the difference between the having and where clause is the where filters before data is grouped and the having filters after data is grouped. Where has no idea what a group is. So this is the important distinction. Rows that are eliminated by a where clause will not be included in the group. This could change the calculated values, which in turn could affect which groups are filtered by the use of those values in the having clause. So for example, here we have select job count star as number of roles from employees where salary is greater than 2000. Then we have a group by job and then having count star greater than or equal to 2. So in this case, we have only two that meet the criteria, analyst and manager, and there are two analyst roles and three manager roles. So if this sounds confusing, you can break the query down. So first get a bigger set of data. So select job count star from employees. So just we're retrieving just the job and the number, the total, the count. Then we have where salary is greater than 2000. So here we just want the job and the count from employees whose salary is greater than 2000. Then we want to group by the jobs which meet that criteria, and we want to only return the values where the total is greater than or equal to 2. So these are the differences between the order by and group by. The order by sorts generated output, and the group by groups rows. Now the order by and group by can be a little confusing, and a lot of people mistake one for the other. So this is a good way of seeing what the differences are. So the order by sorts the generated output, while the group by groups rows. The order by can be used on any column. For group by, only selected columns or expressions columns can be used. And order by is totally optional, but group by is required if you're using columns with aggregate functions. So here you can see the differences of the first query here. Select job count star as number of roles from employees where salary is greater than 500, group by job and greater than or equal to 2. So in this case we have 4 results here, 2, 4, 3, 4 for analyst, clerk, manager and salesman. And then on the right here we can see the same query but with an order by, and then we have the number of roles and job. So in this case we're getting the same result, but that list is just ordered and sorted. It is sorted by the number of roles and the job. So far we looked at a lot of different elements for the select statement. So here's the summary of a breakdown. So you have select, from, where, group by, having, and order by. You should probably memorize this because this is the order in which the select statement will always look like. So you have the select columns or expressions, from, which is the table, where, that's the row level filtering, and group by, that's the group specification, and having, group level filtering, and then order by is the sort order. Now in the required column, you can see that the only thing that's actually required is the select statement. Wait, so what? You don't need the from? No, you don't actually need the from. If you just use select, you can still get an answer. So you can just do select 2 plus 3, and then you'll get an answer of 5. So the select statement does not need anything else. It can completely live in isolation. Now before you get to subqueries, please make sure that you got the previous stuff down really well. Subqueries are just a nested query statement where you're adding another layer or another level. So you're creating a query and then a subquery, and the subquery is going to be part of the original query. Now there are some conditions though. The subquery select statement can only retrieve a single column. There is no limit on the number of subqueries that you can use, but the subqueries are a performance issue. So here's an example. So the first one, we have a regular select query, select ID from employees where job equals manager, and then we just took that the entire select statement and then put it in the where clause. So here we're saying select name from employees where ID in, and then we just copying and pasting the entire select statement from the first part inside that in clause, and then we can use that as the ordered list. So here's an example of a subquery as a calculated field. So in this case, we're saying select name from employees where salary equals, and then a subquery of select max salary from employees. So in this case, we're getting Kaling, who is also the president of the company. so she makes the most money.